Okay, so we talked in a previous video about stereoisomers, and we talked about stereoisomers can come from how stereoisomers can come either from a double bond, right, or a ring system, right, or chiral centers. Okay, so this is what we just talked about. So now let's talk about isomers a little more, and it's going to actually get a little more complicated, and we're going to see some really neat things here. So first of all, again, isomers. They can either come from constitutional isomers or stereoisomers, right? By the way, I apologize for the background noise. I'm sitting next to an open window. It's just beautiful out there, and I can't bear to shut it. So if you hear birds and it makes the video nicer, that's great. But if you hear cars or trains, then hopefully that's not going to be too distracting. All right, so again, remember constitutional isomers, COC or CCO? Remember that? Okay, now stereoisomers have the same connectivity, but they're not superimposable. Okay, we talked briefly in a previous conversation about non-superimposable mirror images like the two hands. Remember that? But it's also possible that we'll have a molecule that's so complicated that it's not only is it not superimposable, but it's also not a mirror image, right? So what might that be? Well, okay, so let's get a couple definitions here. Enantiomers are stereoisomers that are mirror images. That's what I've got right here. Stereoisomers that are mirror images. And diastereomers are stereoisomers that are not mirror images. All right? So write those down. We're going to use them. Now, remember this structure, the structure of cis and trans, right? These are stereoisomers, but there's no mirror that you can put this in. Let me pretend like I'm drawing a mirror here, okay? Suppose a mirror is gray. There's no mirror that you can put this in, right? Where this is what you see, right? So it's a stereoisomer, but it's not a mirror image, right? Not superimposable and not a mirror image. So it's called a diastereomer, all right? Now, enantiomers, remember, have the same physical properties. So see, I'm just drawing this backwards, right? What's that? Bromine, chlorine, and hydrogen. Can you see that this structure 1 is the backwards of structure 2? Okay, so these are going to have the same boiling point, the same melting point, right? Okay, they're going to have the same physical properties. Diastereomers have different physical properties, okay? So these two are not going to have the same boiling point. This boiling point over here is not going to equal this boiling point, right? Because it's a diastereomer. All right, so consider a cyclohexane molecule with 3 substituents. A cyclohexane molecule with 3 substituents. Watch this. The 1 is in the R position, the 2 is in the R, and the 3 is in the S, okay? Just arbitrarily. Let's just suppose that we know that, okay? Now, if this was a mirror image, let me just do it like that for a mirror image, okay? Like a circle arrow. Then this would be S, and that would be S, and that would be R. You see that? 1R would go to 1S. 2R would go to 2S. 3S would go to 3R. And yes, it is a mirror image. Now, what about this one? 1R would go to 1S. Yes. 2R would go to 2S. Yes. 3R would go to 3S. Yes. Okay. So this is also mirror images. And you can see that by looking at it. Look, can you see this? But it won't always be possible to see it the way the picture's drawn, right? You may have to redraw it. But can you see out, out, in? Aha, mirror image. Out, in, out, in, out, right? Mirror image. Okay, so when you have 3 stereocenters, there's also 8 possible stereoisomers, and they're all shown above. Consider the relationship among them. Okay, watch this. I'm going to go to red, This is an enantiomer. This is not. It must be a diastereomer. This is not an enantiomer, right? Because it's not a mirror image. It must be a diastereomer. This is not a mirror image, right? Because it's out, 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 and you got out, in, out, right? So it must be a diastereomer. This is not a mirror image, so it must be a diastereomer. This is, wow, that's also a diastereomer, right? Can you see they're all diastereomers except it's twin? All right, so I got this from our textbook, David Klein. He says, and I think this is really clever. Can you think of a family? Think of this as a family, 4 pairs of twins, right? For a total of 8 children. Each child has 7 siblings, and only one of them is their twin. Okay, can you see that? It makes total sense. All right, so let's look at an example, and we'll be done with this. Quick application. The maximum number of possible stereoisomers, you can put this in your notes. The maximum number of stereoisomers is 2 to the n, where n is the number of chiral centers, okay? So if there's only one chiral center, then 2 to the n means that there's only 2 stereoisomers, and there are enantiomers. But if there's 2 chiral centers, you can have 4. In the previous slide, we had 3 chiral centers, and 2 to the 3 was 8, right? That's what we had on the previous slide. We had 8 possible stereoisomers, okay? What is the maximum number of possible cholesterol isomers? This would be a great quiz or test question, all right? Pause the video, work it out, and come back and watch me work it out then. Okay, so I'm going to assume you paused it, and I'm going to show you what I would do. I would go through here, and I would first of all put an X through everything that's not a chiral center. I can see 2 hydrogens. Where am I here? On that guy, right? Nope. 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 No, maybe, maybe, maybe. No, I need a better marker here. No, 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 maybe, maybe, maybe. No, no, maybe, maybe. No, 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 and no. Okay, so we got to go through the maybes now. All right, I'll get a different marker for that. Let's go with gray. So this is not a chiral center either. Should have said that. But this one is a chiral center, right? Because if you look to this carbon, oh, there's another no right there. Nope. Okay, if you look that way and that way, we see different things. So it's so far 1. Okay? No, 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 no. What about this guy? There's a methyl group right here, right? Trying to write really neatly so we don't booger this up too much. And yeah, definitely different things on either side. So there's another one. 2. Okay, what about this carbon? Yeah, definitely different things on different sides, right? There's another one. 3. Okay, what about this one? Wow, is this getting annoying? I hope not. I know, I hear it myself. So definitely something on different sides, right? 4. What about this one? Definitely something on different sides, right? 5. Definitely something on different sides. 6. Okay. There's one I forgot to mark off. Can you see how my notes help me? They really save me. I'll see everything's been marked when I'm done. Okay. What about this one? Yeah, wow, 7. 8. And that's it. Because that's not a chiral center. That's a CH3, right? 8. What? Wow, 2 to the 8? Man, I can't do that in my head. I'm going to say, let's say that that's 2 squared to the 4th. So it's 4 to the 4th, which is 64. That doesn't sound right. No, that's not right. Something's wrong here. No, no, no. I don't think that's right. 2 to the 8th is 2. Yeah. Huh, okay. I can't do this in my head. I'm going to do it on a calculator. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Is this painful? 2, that's 4. That's 4. That's 4. And that's 4. But I thought 2 to the 5th was 32. Wow, it's embarrassing. Okay, I'm not going to change this video. I'm going to let you see that, yes, I do not trust myself. You shouldn't trust yourself either. Don't just put a number in there. It would be so painful. 2 raised to the 8 equals 256. How did I get that wrong? 2 to the 8th is 56. 256. Okay, I'm going to leave it at 256 right now. That's enough for the video. Good luck. I'm going to check this after the video is up, though, and you should too. Before I enter it in my test, I'm going to check it. All right. Good luck.